Hey, real quick, we're going to go through how to find the electron configuration of ions using our full electron configuration for the elements. So let's get started. So we are going to be able to determine the electron configurations and the charges of different ions. That's our goal. So again, electron configurations tell us where each electron is found in an atom of an element. We use the orbital filling diagram to determine where our electrons go. And then we use this orbital notation here with the number in front, coefficient, the letter of the orbital, and then the exponent tells us how many electrons are there. Once we have the outer electron configuration of an ion, we can determine what the charge of the ion would be by thinking through how that specific element would fulfill the octet rule. Okay, example problem number 1 here. What is the electron configuration of a potassium, or K, and ion? And then what's the charge on the potassium ion? Okay, so what group is the element in? Potassium is found in group 1. What is the atomic number? Potassium has 19 total protons, meaning it has 19 total electrons in a stable element, not as an ion. So just real quick, 2 electrons in the 1s orbital, 2 electrons in the 2s orbital, 6 in the 2p, 2 in the 3s, 6 in 3p, and then it's going to have 1 in the 4s orbital. Okay, so the full electron configuration for potassium is written out as 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. It has 1 valence electron, 1 electron in the outermost shell. Okay, so the highest step or stair step, the highest energy level here for potassium is 4s. So potassium is going to give away 1 electron in that 4s orbital to fulfill the octet rule. So its outer electron configuration becomes 3s2, 3p6, 8, 2 plus 6. I have 8 electrons here in the 3s, 3p outermost shell. Now, I've gotten rid of this 4s1 electron. Now I have fulfilled the octet rule. I have 8. So potassium is happy with a full octet, 8 outer electrons. Okay, that's the goal of any kind of element when we think about charges and becoming ions. So potassium has given away a negative, so it now has a charge of +1. It has 1 extra proton than it does an electron, so it becomes positively charged +1. So now you're going to try a problem. So now you try one. What is the electron configuration for an ion of oxygen? Pause the video, work this down on paper, then check your work on the next slide. Okay, so you should be working through the same steps as my example with potassium. Make sure you first write out the full electron configuration for oxygen, then think about if it's going to gain or lose electrons, what would its charge be? How does it fulfill the octet? Pause the video. Make sure you actually work through the problem. Okay, so you have paused the video. You have worked through the example, checking your answer. The full electron configuration for oxygen is 1s2, 2s2, 2p4. It has 6 valence electrons because the 2s and 2p are on the same stair step. They're on the same energy level. Oxygen will want to gain 2 electrons to fulfill the octet rule. It has 6. If it gains 2, now it has 8, right? Therefore, its ion configuration is 1s2, 2s2, 2p6. It has 8, 2 plus 6 in its outer energy level, which is 2s, 2p. It has 8 electrons. Its charge becomes -2 or 2 minus because it gained negativity. If I gain electrons, I become more negative, right, because I have more electrons than I have protons. So oxygen in an ion form is O2 minus, has a charge of 2 minus. Okay, quick summary. We use the full electron configuration of an element to see how it will fulfill the octet rule, either by gaining or losing electrons, and then we determine its charge. If it gains electrons, it will have a negative charge. If it loses electrons, it will have a positive charge. All right, thanks for watching. Good luck.